In less than 3 years, the first fully autonomous workers will touch down on the surface of Mars. They won't be sent by NASA, and their mission isn't just to explore the red dirt. Their mission is to build a massive, self-sustaining city from scratch. Most people think colonizing a frozen, radioactive wasteland is impossible, or at best, science fiction. But what you are about to hear is a shockingly realistic, step-by-step engineering plan to move 1 million people to another planet. It involves underground robotic factories, alien-like rocket engines, and a 100-year-old chemical miracle. And the wildest part? The countdown has already started. To understand how we survive on Mars, we first have to understand how we actually get there. If you love deep dives into the future of humanity, space exploration, and the incredible science that makes it all possible, welcome to Inside Voyager. Make sure you hit that subscribe button right now so you never miss our journeys into the unknown. Today, we are breaking down Elon Musk's ultimate survival plan for a Martian metropolis, and why this mission is the ultimate life insurance policy for human consciousness. Earth and Mars are locked in a cosmic dance, and the distance between them is vast. You cannot just travel to Mars whenever you want. We have to wait for a specific planetary alignment, a launch window that only opens once every 26 months. Because the journey takes about 6 to 8 months, the spacecraft we send cannot rely on a constant supply chain from Earth. They have to bring everything or build it themselves. Enter SpaceX's Starship. This isn't just a rocket, it is the largest flying object ever created. It is taller than the Saturn V moon rocket and generates twice the payload capacity to orbit, yet it is designed to be fully and rapidly reusable. But here is the massive challenge: Earth's gravity is incredibly strong. To carry the 100 tons of cargo needed for a city, Starship uses all of its fuel just to get into Earth's orbit. So, how does it get to Mars? The answer is orbital refilling. You can think of this like aerial refueling for jet planes, but in the vacuum of space. A Starship loaded with cargo will launch into orbit and wait. Then, a sequence of tanker Starships will fly up to meet it, transferring massive amounts of liquid oxygen and methane propellant. Once the primary ship is completely fueled, it fires its engines and departs for the red planet. To make a civilization possible, SpaceX plans to build up to 3 Starships a day in massive factories across Texas and Florida, eventually launching fleets of 1,000 to 2,000 ships during every single transfer window. But when the first fleet arrives around 2027, humans will not be on board. The surface of Mars is a literal death zone. The atmosphere is composed mostly of carbon dioxide and is 100 times thinner than Earth's, meaning liquids instantly boil and freeze at the same time. Without a strong magnetic field, the surface is constantly sterilized by extreme solar radiation, equivalent to getting multiple chest X-rays every single day. Because of this intense danger, the first colonists will be robots. When the first uncrewed Starship lands in a flat, ice-rich region called Arcadia Planitia, its cargo bay will open to deploy an army of Tesla Optimus humanoid robots and autonomous rovers. These machines are built for repetitive, dangerous tasks. Their first priority? Establishing the power grid. Initially, robotic rovers will shoot tethers to connect to one another and unroll massive, flexible thin-film solar arrays directly onto the Martian dust. In just a few days, an autonomous 10-acre solar farm can generate 5 megawatts of power. But Mars is notorious for global dust storms that can block out the sun for weeks at a time. To prevent the city from dying in the dark, the true heart of the power grid will be nuclear. Small, incredibly reliable nuclear fission reactors, known as kilopower reactors, will be deployed. These solid blocks of uranium use simple Stirling engines to generate a steady, 24/7 flow of electricity. Buried deep beneath the red sand, the Martian soil itself will act as a natural radiation shield. With unlimited nuclear and solar power established, the robots can start building the habitat. Because you cannot live safely on the surface, the city must go down. The next ships will deliver autonomous tunnel-boring machines, essentially subterranean factories on wheels. These massive drills will use hydraulic grippers to brace themselves in the low Martian gravity, carving out a vast underground network as the machine grinds through the rock. It doesn't just discard the debris. Automated trains will carry the excavated Martian rock back to the surface, where it is used to 3D print concrete segments for the tunnel walls. To make these tunnels completely airtight and capable of holding Earth-like atmospheric pressure, robots will spray a special sealant. This two-part epoxy, mixed directly with Martian dust, foams up to fill every microscopic crack. Slowly, this network of streets and corridors will expand into massive subterranean caverns. This multi-level underground city will be heavily shielded from cosmic radiation and the massive temperature swings of the surface, creating a safe, human-breathable oasis waiting in the dark. But shelter and power are useless without water, air, and a way back home. This is where the true genius of the SpaceX plan comes into play. You see, transporting water from Earth for 1 million people is mathematically impossible due to the sheer weight. That is exactly why Arcadia Planitia was chosen as the landing site. It sits right on top of ancient, frozen glaciers. Robotic drills will bore into the ground, melt the ancient ice, and pump liquid water into a massive underground chemical refinery. Using electricity from the nuclear reactors, a process called electrolysis will split the water molecules into oxygen and hydrogen. The oxygen is captured and pumped into the underground city so the future colonists can breathe, but the hydrogen triggers the most crucial survival mechanism on Mars. Using a century-old chemical process called the Sabatier reaction, the automated factory will combine the hydrogen with carbon dioxide pulled directly from the thin Martian air. When these elements react, they create two things: more water and methane. Methane is the exact rocket fuel that powers the Starship's Raptor engines. By manufacturing fuel directly on Mars, the rockets can be refilled for the return trip to Earth. This makes the entire interplanetary economy viable. You might be wondering, is there any other way to do this? Over the years, aerospace engineers have proposed different concepts to reach Mars. Buzz Aldrin, the legendary Apollo astronaut, proposed the Mars Cycler. This concept involves building one massive spaceship that continuously loops in a fixed orbit between Earth and Mars, never stopping. Smaller taxi ships would fly up to dock with it as it swings by. While highly fuel efficient, building a massive orbital cruise ship is an incredibly complex challenge, and it doesn't solve the problem of landing millions of tons of cargo on the surface. Another expert, Robert Zubrin, suggests using a mini Starship. He argues that landing a massive 100-ton Starship on Mars is too risky because the atmosphere is too thin to slow down such a heavy vehicle easily. He proposes launching a smaller, lighter ship from Earth orbit that gently descends to the Martian surface. This mini-ship would require significantly less fuel to return to Earth, only a fraction of the 600 tons of fuel a full-size Starship needs. But Elon Musk's philosophy relies on brute force and massive scale. To make humanity multi-planetary, we don't just need a few astronauts in a tiny capsule, we need heavy industry, construction equipment, and millions of tons of raw materials. A full-size Starship is the only vehicle capable of delivering the payload required to build a self-sustaining civilization. SpaceX is already actively testing the Starship's heat shield, pushing the limits of advanced ceramics to survive the intense re-entry plasma so the ship can be rapidly reused. By the late 2030, the robotic advance guard will have prepared the foundation. But before humans arrive, there is one final piece of the puzzle: food. Growing food on Mars is incredibly tough because the native soil is laced with toxic chemicals called perchlorates. To solve this, the colony's robots will process the dirt to wash away the toxins. To fertilize the crops, they will use a fully closed-loop agricultural system. This includes capturing nitrogen from the atmosphere and eventually recycling human waste. It sounds extreme, but human urine can actually be processed to extract urea, which, when mixed with Martian dirt, creates an incredibly strong concrete-like building material called biocrete. On Mars, nothing goes to waste. Deep underground, powered by synthetic suns and nuclear energy, the first crops will grow. Only when the power grid is humming, the fuel tanks are full, the air is breathable, and the greenhouses are green, will the first human crew depart Earth, targeting an arrival as early as 2035. We are witnessing the most ambitious engineering project in human history. If you want to stay updated on this exact mission and continue exploring the frontier of space and science, make sure to subscribe to Insight Voyager. We bring you deep dives into the universe's greatest mysteries every single week. So, why are we risking everything to go to a barren, hostile planet? As Elon Musk points out, Earth has been around for 4.5 billion years, but eventually, the expanding sun will incinerate our home. More immediately, a single extinction-level event, like an asteroid, a supervolcano, or a global war, could wipe out everything we have ever built. Mars is not just a scientific experiment, it is the ultimate life insurance policy for human consciousness. The goal is to deliver over 1 million tons of cargo until Mars reaches a critical fork in the road of destiny. A point where, even if the supply ships from Earth stop coming for any reason, the Martian city continues to grow and thrive on its own. We are standing at the dawn of a multi-planetary era. A new world, built by machines, powered by the atom, and waiting for humanity to take its next great leap. Thanks for watching Insight Voyager, and we will see you in the next one.